future is here. It will be beyond our imagination. And Generation AI, we're at the center of it. This is our moment to unify everyone and everything, to break down the barriers between artificial, business, and human intelligence, to open up data and AI to everyone, everywhere, and to unlock a wave of innovation from mass participation. This is our moment to become data and AI companies, liberated from the past and open to a wildly expansive future. This is Generation AI, open to everyone and led by those brave enough to become something new. Welcome to the future.
Hello, everyone. I'm Naveen Rao, the VP of AI here at Databricks. I was previously the co-founder and CEO of Mosaic ML, which was acquired by Databricks a little over a year ago. And in the last 15 or so months, we've been really busy on integrating the capabilities from Mosaic into the Databricks platform to provide unequaled capabilities across generative AI, and just orchestration of compute for AI. And I'm here to talk about some of the shifts that we're seeing within the industry and actually give you some product demos going forward. So we're going to run this like a little bit of a general to data intelligence introduction, and then some product showcases and demos. I think this is the most exciting part. Along with a customer panel where we actually show how customers are using some of the capabilities that we built within Databricks. And then a little bit more about a hint of the future of the Meta Llama Foundation models. We were very close partners with that team, and I believe there's a lot of exciting things on the horizon. So it's no surprise, generative AI is really taking the world by storm. We see every Fortune 500 company has some sort of strategy around generative AI, how they believe it's going to transform their business, how they're going to use data differently. 91% of organizations are experimenting with it, so it's really not a surprise at all. And many people do believe it's going to be a competitive advantage, but we do see that today realizing those gains is a bit of a challenge. We do see 40% say that there's an increase in performance of employees who use Gen AI. I would say most of these come in the form of coding assistants and other kind of co-pilots. A lot of what's driven this is just the improvement in models over the last 2 years. ChatGPT was introduced in November of 2022. And since that time, we've just seen massive investment and increases in performance in these models. So what we see here is just the closed models on the yellow line and the open source models on the green. And it's an interesting trend. There's been a lot of investment now into the open source community as well from the Meta team driving this through the Llama models. And we've actually closed the gap between these two things. But at the end of the day, it's about building a system end to end that works for your application built on your data. And at Databricks, we actually embrace both techniques. We want to find the best models that can do generation and maybe visual capabilities, also combining that with the capabilities of customization of those models and systems on your own data. To this end, what we find is that general foundation models are actually not sufficient on their own for enterprise use cases. Enterprises have unique needs beyond consumers. They really want to drive some sort of differentiation in their product against their competitors. They want to customize these things based on their data. Oftentimes, an enterprise's crown jewels are really their data, how they've ascertained their customers' needs, how they've dealt with their suppliers and supply chains. These kinds of things become big competitive advantages for companies within their own markets, and being able to utilize that data to customize models and systems end to end to drive new capabilities or operational efficiencies is really the name of the game for the enterprise. So how do general AI models work? So typically they're trained on a lot of data that came from the internet. This includes Wikipedia, Reddit, all kinds of different sources out there. Many of the data sources now for the closed source models are coming internally. They're able to scrape from news sources like transcriptions from YouTube, but also be able to get feedback from their own users. An interesting tidbit here is that more and more of the world's data is actually generated. So it's going to be interesting how this works going forward. I think data quality starts becoming a very important metric for LLMs. But we generally characterize these models on generalized benchmarks like MMLU, where they cover a variety of different topics like nutrition, religion, astronomy, etc. And these are useful for building something that can chat like a human. Most humans have some general knowledge across many different subject areas, and you can talk to them intelligently about this. However, even with humans, when we do our jobs, we actually become very specialized. We use specialized jargon and other things. And really, this is where we start to drive a lot of economic value for the enterprise. So being able to answer questions on broad topics is useful. It creates wonderful demos and perhaps can be useful for a variety of consumer needs. But what do our enterprise customers really care about? They want to know, was their own support case resolved to customer satisfaction? This can be really specific to the company or to their customers. Are users accepting AI generated suggestions in my app? I mean, this again is something that's really specific to a particular company. Is our AI representing our brand well? In the end, what enterprises really care about is grounding these answers to some sort of truth that they have owned. Here's a set of data that we have gathered over the last several years about the usage of our product or how our users want to use that product. And we want the answers of the system to be grounded in that data. We actually don't want it to deviate. We don't want it to have too much general knowledge. Even if there's some fact that may be wrong within that data, these customers actually want to control it and have something that's reliable and repeatable. That's really more important often than making something entertaining or other things that consumers might care about. So grounding the output to real data and controlling what those data sources are is actually extremely important to the enterprise. So we kind of coined this term data intelligence, and really it's to differentiate from general intelligence. General intelligence is general. It can answer questions on broad topics. It can potentially even integrate concepts across some of those topics. But data intelligence is really using your data to make something that's really specific that services your application, your customers, your users the best way possible, and doing this in a way that gives a competitive advantage to an enterprise. So the challenge we see here is that it's really difficult to build these kind of applications for the enterprise, things that are truly grounded in their data, things that are secure, things that actually have proper governance around them such that different users cannot access data they're not supposed to have access to. And this actually has prevented 90% of enterprises from going to production. They've all started proof of concepts, but they've not been able to move those into production because of these kind of plumbing issues, really. Being able to develop in an environment, be able to take that model and system that's been developed and then put it into production from that same environment just simply didn't exist. So the value of Gen AI is the ability to do this kind of bespoke reasoning capabilities over your data. And in order to do that, you need to have all the safeguards and security that are required to deal with sensitive data. As I mentioned at the beginning, data becomes a company's crown jewels. That's the thing that differentiates them. It provides a competitive advantage in their own markets. So this data has to be protected, has to be governed, and any Gen AI model that's built off of it or utilizes it also needs to inherit that kind of security posture and governance. So what are some of the challenges in building production quality AI solutions? So as we mentioned, accuracy. Accuracy is really not a general thing. It is something that's really specific to the application. If you're doing customer support for your own product, accuracy means that you provided the right answer to the question that the customer or user cared about. It's not something that's a general topic where it's like you can say facts that are correct, but they aren't relevant to solving the problem. So accuracy is really specific and actually requires often bespoke evaluation. Governance is the idea of using the right data at the right time. So if I have some data that's across many of our users, I shouldn't be able to serve that data generally to all my users. So if there's a support ticket filed and I want a bot that can go through and talk to the user about this, I can't pull data from other customers or other support tickets that might expose some details about their usage. We really need to keep all of these things separate. And this seems like a simple concept, but it actually becomes very complicated in practice when you have many different types of user entitlements and access control lists and many different types of models accessing that data. So we really need to have a system to keep these things in check. Cost. This actually, surprisingly to me, was one of the number one things that enterprises care about. What happens is you go through the process of building a POC, you get something working, and then you want to roll it out. And once you start to extrapolate the cost from that POC, it becomes cost prohibitive. Even if it's cheaper than one human doing one task, when you roll it out to 100,000 users of your platform, this may not be true anymore. And so it starts to become actually a big burden to roll these things out, which just prevented rollouts to production from occurring. So cost has actually become an extremely important thing to optimize around. And there are many different tools that we have inside of Databricks that actually help with this. Things like re-ranking or building better embedding models with your vector database, the vector database itself. All of these components can actually lead to higher quality and reduce costs at the same time. So getting to production requires us to get to a cost envelope for our end-to-end solution that actually is a realized ROI for the company. So accurate outputs, as I mentioned, customizing this with enterprise data is really the key. Making sure that answers are grounded in the data that you care about is actually extremely important. In some ways, we almost don't want the LLM, the generation LLM, to be too smart. We want it to know how to reason over data that's been given, that's domain specific, and then provide the right answers that are grounded in that data. Unified governance, this really brings order to the chaos. There can be tons of different users accessing different kinds of data, and really having this systematized becomes extremely important. As I mentioned, we are continuously driving down the cost of building Gen AI systems. Part of this comes from being able to modularize, which I'll talk in a moment. Some of it comes from optimizing smaller models around bespoke data. This actually goes back to the production quality pillar as well. So if I can make a smaller model work within my domain at the performance that's required, I actually have lower costs and lower latency. So a really great example is a customer of ours called FactSet. FactSet is a financial services company that actually has their own query language. So they provide a source of truth for public companies' documents like 10Ks and things like this. So they actually built this language because their database has some particular usage patterns that are a bit different than maybe SQL. They call this FactSet query language, or FQL. So traditionally, a user of FactSet had to know FQL to be able to pull data out. Again, this is really nice and precise, but if you are a business user, you may not know how to write FQL. It's more like code than it is like English. So they wanted to actually add an English front end so they could open their user base up to more and more people. So instead of having to write a query like we see on the right here, we could potentially say it in English and give me the current year and trailing EPS for all US listed equities. They first tried to build something using prompting, in this case, OpenAI GPT-4, and they did get something that works. It wasn't terrible. It was in a proof of concept kind of environment. And basically they got to 59% accuracy and the latency was 15 seconds. This accuracy means that English statement actually produced the accurate FQL code that will pull the right kind of query to answer the question. This wasn't at their quality bar for production. They couldn't quite get something out to their users, and really they needed something more. What's really nice about this is that it actually gives you the targets to shoot for. We know it's 59%. Okay, go and establish what is the bar to make it production worthy. What's the bar for latency to make it production worthy? Once you've characterized these things, you can actually go back and try to fix them. And within Databricks, we have lots of different tools to increase accuracy and decrease latency. One of those tools is this concept of compound AI systems. There's a blog written mainly by Matej Zaharia, who is the CTO and co-founder of Databricks. Several other folks authored this blog as well. And the concept is simple. It's really that when we engineer end-to-end solutions, we don't think about them as one big monolithic model. At the beginning of time, when LLMs were new, which was just 2 years ago to most people, we tried to put all the smarts into the LLM, all the knowledge into the LLM. This is good from the perspective of it's simple, but it's difficult to make it accurate. It's difficult to understand exactly what kind of response the LLM is going to give. So now when we start thinking about engineered end-to-end solutions, we actually want to break it into modular parts. We want to say, okay, well, there's certain parts that are actually just either table or database lookups. Let's make a function that does that. We can now make our LLM call a function to get the data it needs to answer a question. We can also make things embedded into a vector database. Instead of having to put all the knowledge into the LLM and train it every time, we can embed knowledge into a vector database. We can actually make the LLM match against certain knowledge that provides grounding for an output. So basically, this increases quality and allows us to use data within our own database without changing the model. So these are all techniques for making something higher quality and bespoke and modularizing the whole solution end to end. In this way, we can actually test each module in its own environment. And when we stitch them together, we have a much higher chance of this thing working reliably end to end. So in this particular case, we actually did build a compound AI system with FactSet. And we built a fine-tuned open model as a query processor. So it's reformulates the English query to make better FQL output. Then the formula retrieval, so that's a vector embedding. Then we actually use a commercial LLM to generate some arguments based upon a vector database. And then finally, we construct the final output, which is the FQL code. And with this, it was actually faster end to end, even though it's multiple components, because each component is small. We could do it in about 6 seconds end to end, and we achieved an 85% accuracy. This was above the bar for them to go to production. And if you use their tool, you are using this end-to-end system that was built within Databricks. So key components of a compound AI system really are data prep. That goes into everything we do for AI. Everything starts with the data. People have been doing ETL on Databricks for many years. Then model selection. This is something that we have a library of different models that our users can choose from. They all have different capabilities, and those models can be customized. And a production deployment. This is really versioning each component and doing the things you need to do, all of the plumbing, if you will, of getting things into deployment with version control, with all the scale and failover required to make it work in production. And then finally, evaluating the model or evaluating the system is extremely important to understanding what the performance is, what things can be improved, where do users have problems. You need to actually characterize this, log it, and continuously improve. And of course, all of this is under our unified governance called Unity Catalog. So some of the product names associated with this, with data prep, Lakeflow and Mosaic AI Vector Search actually does a lot of the prep, embedding the data to put it into the vector database. Model selection, as I mentioned, we work closely with the Llama team from Meta, and we actually have all their latest models available as soon as they launch, which has been a really great collaboration. In addition to that, we provide ability to fine-tune these models with Mosaic AI model training. So you can actually take your own data that might be domain specific or something like that, modify the model and make it work better for your purposes. Again, develop that component on its own, evaluate it, make it really great for your solution, and then plug it into the rest of the system. MLflow is our production environment. This allows you to do logging and monitoring, version control, all of the things you need to go to production. And this is managed within Databricks itself. And then the Mosaic AI agent evaluation framework actually is quite powerful, and we're adding a lot of new components to this. We want to actually automate evaluation of these end-to-end systems completely. what you really want to do is be able to start with an English description of the task and then have the system figure out, does it really accomplish that on its own? Today, we're not quite there, but it's actually getting closer and closer to this ideal. And we're within a few months of actually having something that you can simply define the task in English, which is, I think, going to be a big game changer. And because of these new capabilities and the speed, the velocity at which we're shipping new features, we're getting recognized as an industry leader in Gen AI. Building the models, the foundation models is one thing, like OpenAI, Meta, Anthropic. But putting these things together to make end-to-end solutions actually work is a completely different thing. This is not something any of those companies do. So Databricks is recognized for basically orchestrating these components, having the knowledge to understand what enterprises need, what their specific needs are, how to customize the system, how to make it reliable. And you can see here we're a leader in the Gartner Magic Quadrant on the left and a leader in the Forrester Wave for AI on the right. So we're very excited about this. And we continue working with these folks to demonstrate how we're adding value to the enterprise. And many enterprises are trusting us now with their Gen AI. We're continuously working with more and more customers who are using all of the tools within Databricks, model serving, model training, monitoring. The automatic evaluation is just now starting. So all of these components are able to get these folks from POC into production with all the monitoring and improvement capabilities required to keep making their solution better and better. All right, with that, I'm going to pass it over to Brian and Antoine, who are going to do some demos and showcases of industry solutions, starting out with a retail demo. Thank you.
Thank you, Naveen. My name is Brian Smith, Industry Solutions Director for Retail and Consumer Goods here at Databricks. I want to take a moment to touch on a challenge highlighted in Naveen's presentation and explore how many retail organizations are overcoming it. Earlier, Naveen mentioned that the vast majority of Gen AI solutions never make it out of the POC or pilot phases. While there are many reasons for this, one core reason we've observed is that often organizations are looking to completely reinvent their work processes or create new work processes altogether using generative AI. Getting the business to embrace such a radical change requires a lot of buy-in, and so technical, governance, and cost concerns get amplified, and we get blocked before we can get into production. What we're seeing us working with many of our retail customers is that they take a more incremental approach, where the focus is more on augmenting and enhancing existing processes. These projects focus on more incremental changes, have a better chance of winning business support and being moved into production. Let me show you one example of this. Imagine you run an online website. You have hundreds, maybe thousands, maybe a whole lot more items that you need to present to your customers. For each one of those, you need to craft a page that looks something like this, where the item is presented to the user. They can get a clear look at it, and they can read a bit about it through a product description, helping them make a decision as to whether this is a product they want to purchase or not. Now, if you focus on that product description there in the middle of the page, I want you to imagine there is someone in product marketing or merchandising that's having to look at this item, read the supplier's documentation on it, and think about the audience it's intended for. Think about the language they use on the site, the language that's used by the brand, and then bring that all together to craft a description that you're going to see here on this page. And they need to do this for tens, if not hundreds, of very similar products, making sure that each is described in a unique and compelling way. This is a very time-consuming process, one that we can accelerate with the use of generative AI. Let's click over to a demo. Here I have a simple UI that lists some products that we need to put up on our website. I want to focus today on some soccer cleats. I do a little search, click on the item of interest, and here we go. Now, once this item comes up, you can see that I have the name of the product, some metadata provided by the supplier, and a product image. Behind the scenes, we use generative AI to extract a description of this image, but the description that I want to put on the website is not here. So I can come down to the copy generation portion of the UI. I can see I have an editable prompt, and it's incorporating much of the information that we saw before. I can go into the dropdown. I can select a model that I think is going to be appropriate to give me a product description, and then I can generate some sample descriptions. Now, each one is a little bit different. And so I read them carefully, and I grab a sentence or a phrase from one and then something else from another. And I come down here and I cobble together a draft description that I'm going to put onto our website.
And here we have generative AI helping me get that initial draft out the door much quicker than if I had to sit there and just stare at this product on my own. Now let's take a look at this one more time. How about we decide to work on some of these new water shoes we need to get up on our site? We select our item, we review the content, adjust the prompt, select our model, generate our product copy. Again, we grab the parts we like, we make a few manual edits maybe, and then we submit the description for review. Pretty simple process and very powerful in terms of the impact it has on our ability to get products out the door.
Let's take a moment to think about how we pulled together this application. We started by loading our product information into the Databricks environment. We brought in product metadata, technical specs, other information our suppliers delivered to us. We also brought in product images. Now, our suppliers may have given us a basic product description, but we could use generative AI to help us extract an additional description from these images, supplementing the information available to us. We might also have data such as key search terms that our customers have been putting into the site that we think are relevant to these products. We might want to make sure that we incorporate some of those terms into the product description so that when customers come and do a search on our site, they're likely to find these specific items. All this data is loaded up into the Databricks environment and then combined to form a prompt. That prompt is delivered to one of any number of LLMs supported on a platform, and a draft description is generated. The product copywriter then cobbles together a description that's then submitted into a lengthy review process, not shown here. And I do want to make sure that we don't minimize that specific process, where there's a series of reviews and edits that are going to take place before the final copy is then eventually settled upon. But eventually, that finalized copy is going to make its way downstream into an e-commerce site. Now, while it wasn't shown here in the demo, what we can do is we can take that finalized copy, if we've captured it inside the Databricks environment, and use it to fine-tune our LLMs, so that over time they better learn the style and tone that we like to use, and therefore learn to give us draft product descriptions that are better aligned with our needs, further accelerating our work. What's great about this solution is that it's focused on enabling a function in the business we are already committed to performing today. And what's great about using Databricks for this is that it gives us a means to tackle each of the steps in a compound AI system without having to bounce between a bunch of different platforms. We can load our data, both structured and unstructured. We can apply transformations, including those using generative AI, like where we extracted descriptions from our product images. We can access a variety of models and then connect our data with those models to generate the results you previously saw on the screen. As proud as we are about the Databricks UI, the reality is that most of our business users will want a custom UI purpose-built for their needs. But no problem, we can deploy the models, connect the data, etc., from a variety of custom UIs built on or around the Databricks platform. And while it wasn't shown here, we can capture feedback from our users and fine-tune our models on that feedback to help improve the system over time. All of this is available through a single platform, simplifying the technical work behind developing solutions like this and allowing us to focus on delivering business outcomes for our organization. Now, I'm going to hand this over to Antoine Amin, who's going to talk to you about another generative AI application that we're seeing widely adopted in the financial services space. But before I do, please allow me to point you to this blog from Tristan Whitland, where he addresses the product copy generation scenario shown here today. If you read the blog, you can learn a bit more about product copy generation process and then access a series of free notebooks showing the code behind the workflows we've shown you today. I encourage you to please take a look. And with that, let me turn it over to Antoine.
Hi, thank you very much, Brian, for this exciting demo on Gen AI for retail and consumer good. My name is Antoine Amend. I lead our financial services vertical. And just like Brian, my job is to bridge the gap from a business to technology and to look at our platform in the shoes of an end user in insurance, in retail bank, or in capital market. And so for the purpose of that demo today, I want to put myself in the shoes of a portfolio manager and to look at what are those key challenges that they face on a day-to-day basis, where they spend much more time having to go through all those documents available online, 10Ks, 10Qs, earning call, transcript, and therefore less time on building new investment strategies and building relationship with their customers. When we've seen an explosion of data over the last few years where a lot of market trends, analytics may be available in non-mainstream sources like news articles, social media. So if I could automate all of those tasks, I will be able to free up a lot of time actually building strategies and providing my customers with financial advices. Furthermore, I could bring much more objective advices in a world where lots of information, specifically around ESG, may not necessarily be always objectively and quantifiable by nature, leading to potential inconsistency about what I define as a sustainable investment. So in all that playground is a perfect playground for GenAI capabilities to shine because of its ability to summarize content, to translate from one language to another, to extract initiatives, to identify valuation metrics, to summarize, to extract the sentiment. And so you can think of all those capabilities as tools in a toolbox. And now we can leverage the concept and the architecture of what we call the compound AI system to be able to articulate and orchestrate all of those different tools and capabilities to drive a specific business outcome. So let's look at an example of a simple portfolio manager app, an application, as we've seen, every day, but now that is being embedded with GenAI capabilities. And what will that change as an end user? So imagine that I am a portfolio manager, and I used to spend all my mornings doing some market research and analysis, and then spending my afternoon building relationship with my customers, providing them with advice, getting them on a call, and so on. So I have my same application, but this time I have access to an investment assistant, to a portfolio assistant, where I can start describing specific tasks, specific action, such as I want to summarize what I know about Ron Gabrisco, one of my most demanding investors. Just have a quick view, high level about his investment profile, the key holding, some insights, and some follow-up questions. I can start asking specifically about what is a risk factor in Ron's portfolio. And with the right amount of prompt, and if not even a fine-tuned model, but a model that understands my data, not a off-the-shelf generic model that understands just English in general, but a model that understands my data, then I can start driving analytics around potential risk exposure to a specific segment. So there is an obvious lack of diversification in Ron's portfolio. And as I prep for my meeting with him, I can start asking further questions. And in this case, if I ask GenAI about how happy Ron is as a customer, one, only a model that understands my data will be able to come up with those kind of outcomes. But two, generative AI, deductive and reasoning skills will understand that to answer that question, I need to call the right tool, the right agent that can connect to my Salesforce data and bring the full history of conversation that I've ever had with Ron. Now I can carry on with my analysis. I understand that potentially I will be talking about lack of diversification. I can start investigating a specific instrument, such as in this case, Google. I know that Hans owns thousands of shares, and I can bring some fundamental data like PE ratio and a number of outstanding shares. So all of that data can be surfaced from my online table, from my Databricks analytics platform, and incorporated into whatever GenAI capability that I want to bring, which in this case, if I want to describe who Alphabet is, I don't want a generic description of Google. I want a description of Google as it pertains to Ron Gabrisco's investment profile. Similarly, I don't want to just simply read news about Google. I want to be able to summarize quick insights from what is being discussed in social about Alphabet and why it matters to that specific investment profile that I'm looking at. Having that simple sentiment analysis extracting key themes and categories being discussed, so I can quickly get at my fingertips a wealth of information that I can incorporate into my analysis. Combining external data, but also financial metrics and financial data, as I used to do in the past of reading all those earnings calls and transcripts and filings. But now I have an assistant that can call the right model, the right tool, that compound AI can understand that to answer that question, I'm gonna have to summarize that document, extract key financial metrics, and return that in plain English as an exec summary. So now I'm in a position to better advise Ron about the next best investment of his. I can start again asking another question that reflects into another task from GenAI, which is to condense everything we've just seen today as a simple email that will be in my inbox and available for me when I will get Ron on the line just later. And so with this, I have all information I need to know at my fingertips and already saving a lot of my time so that I can move on to my next demanding customer, who is in this case, Oprah Winfrey. So that was just a simple example. We are not building a dedicated application. We're just showing how generative AI could be used as an assistant, but not as a simple chatbot capability, as a generic assistant, but as a capability that understands your objectives, your tasks, and most importantly, that understands your data, so that we can convert a plain English question into dedicated tasks, action, automation, and technical capabilities. So without further ado, I would love to hand over to Casey, and this awesome panel will be talking about the future of generative AI in their respective industries. And as always, if you have any question, feel free to reach out. Thank you very much for your time. Over to you, Casey.
Thank you, Antoine, for your demo. Hi, everyone. I'm Casey Uhlenhout. I'm a product manager at Databricks. And now we're going to talk to 3 of some of our most valued customers at Databricks about their use cases in generative AI. All right. Thank you all so much for joining us. We really appreciate you all taking the time to share your experiences, building, like what you're building with Gen AI, and sort of like the challenges and the benefits that you've seen from working with Gen AI today. So maybe before we get started, can you all briefly introduce yourself? So name, company you work for, your title, and kind of what you're responsible for at your organization. And then we'll kind of dive thick into, hey, what are you building with Gen AI, and go from there. So maybe Vijay, can we start with you?
All right. Hey, my name is Vijay Sankaran. I'm from State Street. It's one of the world's largest financial services firm with interests in custody banking and asset ownership and management. We also have interests in the area of investment management with one of the largest operations dealing with, and it's one of the earliest providers of ETFs, as you might have heard of them. And in our space, we have a bunch of interaction with generative AI solutions, specifically because we end up with dealing with a lot of documents in our world, and these are financial statements and transaction documents. And we also have a lot of need for a number of different research, data-based research needs across the company.
Shamir, can we go to you next?
Yeah, absolutely. I'm Shamir Mirza. I'm the Senior Director of Data, AI, and Machine Learning and R&D. So I lead both the data platform and the innovation groups. And I work for 7-Eleven, which is the world's largest convenience retailer.
Awesome. And Lindsay?
Lindsay Michaud. I'm the head of data science for Providence Healthcare, a large West Coast-based not-for-profit healthcare system, 50 plus hospitals, tens of millions of patient visits. I'm in the IT department, so I have platform responsibility to support the enterprise. We have a federated model with data science and AI. I also build full stack vertical solutions, which I'm really excited to talk about today.
Awesome. All right. So a lot of our customers at Databricks are trying to figure out, hey, what should they build with generative AI? And then how do they get ROI out of these use cases? And so Vijay, when we spoke earlier, you had mentioned, hey, there's sort of like 3 ways to get value from generative AI. So like, hey, you can either get productivity gains, you can build a net new product, or you can have customer improvements that you're launching. So kind of like loved that framing. So maybe given that, can you like walk us through one of the use cases that you have at State Street? That's one of your most like strategic generative AI use cases that you all are building there.
Definitely, thank you. So the along those 3 dimensions or axes that we typically measure all our products that we try to build out. Let me start with the customer delight or customer experience improvement kind of things, right? A lot of these millions of trades that flow through our systems over the every single day tend to have a lot of human touch required. And whenever that happens, we end up with, having to, it's not just customer support in the traditional sense. In many of these cases, it is simply tracking and actually canceling a trade that was issued by an automated system. So in all those scenarios, we end up having to conduct research on where is it in the overall trade clearance workflow and halt it there. So one of the new things that we are innovating on is the instruction comes to us in forms of documents. The data for our transactions is already in large systems, including mainframes, which we end up having to have copies of and data lake oriented structures. Right. So we're building out a full-fledged platform that is going to do smart research in terms of locating where in the workflow it is, and then specifying also, okay, what needs to happen next in terms of, and the latest innovation that came out just about last week from OpenAI with their Strawberry model, which allows us to think in several steps. That's essentially what we were building out, but that's definitely upending a little bit of our work, or probably accelerating some of our work in that space.
Got it. And so what is the business value that you're delivering with this sort of like document-centric automation that you're building out?
There are 3, again, it clicks on all 3 of our axes. Like first is the customer delight, which is what used to take approximately 2 to 3 hours in some cases, is now being, the time scale is being compressed. So the customer is able to get what they want much faster, right? That also translates into productivity gains at our end, which is this whole notion of having lesser touch on our employees, from our employees. And then, of course, the new product introduction, we haven't yet gone in that direction fully, but there's a lot of thinking going on about how to present this as an offering to our customers as well.
Awesome. And then Shamir, can you kind of walk us through at 7-Eleven, what are kind of the use cases that you all are seeing the most excitement around in your org, and how does that align with like what you all are doing on the bleeding edge versus, hey, where is actually the most value being delivered?
Absolutely, yeah. So we've done a lot of really cool things at the bleeding edge in terms of personalized search and all these other things that we're piloting and trying out. But really where we've seen the most excitement is simple data answering bots. So we've trained LLMs, but what we find is just using the out-of-the-box models, especially the existing Genie API with data rooms, has been a super effective method with a consolidated data set for people to be able to ask questions and receive answers that are meaningful. And so we're currently working on exposing that through the most commonly used platform for communication at our organization, which is Teams, because people aren't logging in to Databricks to do this. Typically, they're pinging an analyst on Teams to say, hey, what did sales look like for the Southwest region at this time compared with the previous year, right? So being able to just ping a Teams bot rather than hunt through, find the analyst, and hope you get the right answer has been very exciting for the business.
And is there something about 7-Eleven in particular that makes it so that your business owners and stuff need to like better understand what's going on in like their area, or what's kind of like the value that people are really getting being able to like talk to their business data or their like retail data?
Yeah, the biggest thing really is that we have just about 14,000 locations in the US alone. And we do something called Retailer Initiative. We're hyper-localized, and we really care about how our stores are performing based on the local markets, right? If you go to 7-Eleven, we want you to know the cashier, we want you to know the assortment, and it's unique to your region. So we are focused on really understanding how each store is uniquely operating and how each region's uniquely operating. So sometimes discovering those insights at a very micro geographical level is very important to each of our area leaders who are looking at that data. So we haven't gotten to the point yet where we've exposed these bots to those leaders yet. We're in the process of letting the executives look through them and interact with them. But the next step naturally is to allow field-facing individuals to leverage this data more naturally. Today, they just rely entirely on Power BI reports.
I see. Yeah. I've heard that sushi in the Japanese 7-Elevens is like the best in the world. So makes sense about the hyperlocality. Also, and then Lindsay, I think you have sort of dived more into the like, hey, how can we use Gen AI to build new products? So can you kind of walk us through what you're doing at Providence Health with generative AI and kind of what's like the most strategic use case that you all are working on there?
Yeah, and for context, the portfolio is pretty big, but I'm going to tell you about, I think, the most interesting, the one that I like the most, and I think that when all things shake out, might have the biggest impact. So the use case starts with our Institute for Human Caring, led by a palliative care doctor. Doctors, clinicians get about 15 minutes of training to deliver end-of-life news to families and patients. The actual conversation takes 20 minutes to an hour. So you can tell that's not enough training. It's bad for patients. It's bad for the physicians. And so for some years, we've had a program to train people in how to have these difficult conversations. The problem is we have tens of thousands of clinicians, caregivers, as we call them. So we just could never scale. Like we were hiring actors, or we would pull clinical staff off the front line and have them play the role. They would be their coach. We could just never train everyone the way we needed to. And recently, based on some really fascinating and emerging research that shows that humans seem to really like the way AI communicates around like medical issues. Like we find AI empathic, which is a little bit surprising. We started to build an AI-based training and communication coaching platform where people could learn and practice these difficult conversation skills for the core initial use case of palliative care conversations. And part of what I love about it is that, so we have a working, beta or first version. It's in testing. People are starting to use it. There's tons of feedback. And what we quickly saw is that large language models don't behave the way humans do in these conversations. We fine-tune them to be very pleasing, to be verbose, to communicate like everything all at once. And so we actually have to unwind some of that. And so the cognitive architecture that we've developed is highly agentic, has dynamic prompts that update as we flow through the graph of the conversation, and requires RAG to be inserted at specific areas. The value is obvious for palliative care. It's like saving money in actors. It's also making us better people. But you can imagine there's a lot of other things you have to train workers on. Difficult performance conversations, diversity and inclusion, diversity pronouns. There's a wide list of use cases that provide that just like for automation, as well as upskilling, as well as like the mission-driven work that we hear the most about.
Right. Yeah, because that's like it's like not just augmenting people, but it's also like helping make them better themselves.
Yeah, that's what I love about it. I mean, we do need to save money. Healthcare is money losing situation for not-for-profit, but so that matters. But like the core is to be better.
Awesome. Okay, so that's super helpful because a lot of people have no idea like what's the spectrum of Gen AI use cases that people are doing. So I think that was like an awesome variety of like RAG, agentic architectures and stuff. So now we're going to kind of dive in to that specifically, where what we found at Databricks is many of our customers are really struggling to get to quality. Like getting quality Gen AI apps into production is hard. And so many of our customers are finding ways to sort of embrace data intelligence. So by using their enterprise data to improve general intelligence to achieve quality, or they're using compound AI systems. So rather than shipping like one monolithic model with like maybe like a huge prompt on it, you're actually breaking it down into like modularized components where you can like specialize each component. So can each of you kind of like walk through how you're either using data intelligence or like a compound AI system to improve the quality of the applications you all just walked through? So we can start with Lindsay maybe, because we just ended with you. So we can start on, you kind of like alluded to already, you're kind of building a multi-agentic solution, and then kind of like.
And it's timely because this is the thing we're talking about a lot on my team. And just generally, I think when Gen AI launches, it's so easy to prototype something in ChatGPT with one prompt, right? You just think if you can tinker with your prompt a little bit more, like
Right.
you're get to the outcome you want. A key lesson for me is that that's an evolutionary dead end. Don't tinker with prompts, endlessly think like comprehensively design the system and like the sequence of events that need to happen to deliver value. I usually think of that as a graph. So I encourage folks.
Is this because you find modifying the prompt becomes too unwieldy or is like too unpredictable? Or what's led you to like move from that to system thinking?
That I've just seen in one, that you can get such wild swings in behavior by changing one word in a large prompt. Like as an example, in the empathy use case, when we said, you are a patient, 45 years old with knee pain named Lindsay, like that generated like very unrealistic behavior. When we said, you are a professional patient named Lindsay, just inserted that one word, suddenly they started talking in a way that made a lot more sense, because professional patient is a term of art that you'll find in like Reddit or something like that. And like that unpredictability and that kind of like variance, right? As you're kind of basically like kind of pointing the attention heads at something else so wildly, like I don't like the trial and error bit of that.
Yeah.
Also, practically, I found that like, I'm a leader. I want everything fast and I want it like awesome. And so I found that my teams were too slow. Like they would just get in the cycle where like, oh, it's not quite there. Let's tinker and then let's come back next week. And you get in this cycle. And so we were doing AI engineering in a kind of like kind of free form way, rather than doing it in the way we would do software engineering or data engineering, where you have specific criteria at each step of the way. They're testable, like when you're done and then you move on. And you can also apply other like prompt development frameworks like DSPY or something like that.
Right.
Kind of treat the development in the normal way we build software.
Yeah, real quick. So Shamir and Vijay, I saw you nodding at when Lindsay was talking about the prompts being tricky to manage. Is there like quick anecdotes or like similar challenges that you all have had there they want to share real quick, and then we'll dive deeper into Lindsay's multi-agentic architecture?
Yeah, I mean, for us, especially with user questions related to sales or other data, we wanted to give a real, very valid answer. And so having an LLM perform non-deterministically is a risk that I'm often not willing to take when it's related to either store performance data or financial data or any query anyone has. So we've been using embedding models to route rather than agentic flows. We're starting to look into agentic flows as a way to do this effectively as well. But as of now, we're using embeddings. And I can share some of the architecture diagrams to show you where we're at today and where we're trying to go.
And for us, it's the prompt engineering, as I think Lindsay might have been hinting at, leads us to a dark path, because the document, in our case, even if we keep the prompts the same, the variety that we face in the documents that are coming towards us from the market, actually the data demographic changes. And as a result, the response changes. And so we start looking at a different part of our operation just because in the document structure was different, or the words used in the document were different than what the whole solution was set up to do. So what we end up doing is a lot of like pre-processing the document, categorizing it, classifying it, using both older machine learning based and machine vision based techniques, as well as figuring out how to deal with RAG inaccuracies by using knowledge graphs in addition to the original RAG itself.
Okay, so then Lindsay, so I think what's kind of interesting about your case is you're like dynamically changing the prompt to like the patient agent, right? So you're like adapting it as the conversation goes on. So can you tell us a little bit about like how you architect and like what's like an example use case through that architecture?
So the fascinating piece of doing the design, and we just spent like an all day on-site, is to design the AI architecture. We had to think cognitively. I'm a neuroscientist originally, so I was like, it was great to go back to the well. So we were talking about things like how do you express acknowledgement of someone's emotional state? How do you understand it? Like, it was like, that is not a thing that we would normally be talking about in a technology development session, but we had to discuss it, put it on a graph, and then define some quantitative criteria. So for this patient agent, they have a medical history. They have a demographic history, like age, gender, location. They have some permanent characteristics, like, they're very obstinate, they're very self-directed, and they have transient characteristics, like they're nervous, they're sad, they're talkative. And it's those transient characteristics that change through a conversation. I think that's intuitive to people. Like, you sit down with someone, as you become comfortable with them and they acknowledge your emotional state, you'll open up, you'll tell them things. Or if they're mean to you, you're going to start responding in different ways. So the transient psychological characteristics are what update as you flow through the conversation. And critically, that's where agents, like, kind of one of the places they step in is they're evaluating like the conversation on both sides, and they're looking to see where the doctor has expressed in a positive way, like an understanding of the patient's emotions, and then the trust can rise, and then the verbosity can increase. And so that's just on a mechanistic level, that's an updating of the system prompt. There's also an agent looking to coach the doctor that has access to the internal state. So it can stop the conversation and say, hey, this patient's getting really angry. They haven't told you yet, but inside the temperature's rising. You might want to rewind the conversation and try again.
Interesting. Wow, that's fascinating. And so how many agents are kind of contributing to this multi-agentic architecture that you built?
There's like 4 core phases of the conversation. So I think we have like 9 or 10 agents that are in like something like that, that we expect to interact.
Awesome. Yeah, because I think for a lot of people, they understand the concept of a compound AI system, but they don't really understand like what is it? Like, what is exactly? So maybe, Shamir, can you kind of like walk us through what the like compound AI system is that you all built at 7-Eleven?
Yeah, I'll go through 2 things. I'll go through the first version. I have a document which may help follow along. So at a basic level, the first version of it that we built was user submits a query. We use a text embedding model and LangChain to do a loader, basically with face. And essentially, we make sure it's a valid query. Then we choose the LLM based on the text embedding model, and we do the general processing, right? Where we're headed is more towards using an LLM node to do some of the selection of where to route things, whether vector store, Genie API, Confluence. We have a number of different tools we use.
So you are going to use an LLM to do routing?
Eventually is what we're attempting, because right now the embedding-based model is working and we're happy with it. But long-term, what we've seen is that as the complexity of our use cases grows, right, as we expand the number of data sets that we expose as data products, how do you ensure the routing is consistent in a way that there may be overlap between certain data sets, right? Like merchandising may look at sales a certain way versus how marketing looks at sales. So how do you make sure you route both sales queries correctly depending on the context? And so here we're doing a couple of different things with a document grader. Then based on relevance, an output generator, we validate that there aren't any hallucinations using an LLM node. And if there aren't, then we move on to the answer grader. And finally, whether it answers a question. So this is still a RAG-based approach with multiple agents throughout that process. But this is still early stages for us, because as vanilla as this is, it works. And we've seen great success and users are happy with this. The reason we're looking at the future facing is because in many ways, LLMs, as you're seeing with O1 and others that are coming out, they're becoming more and more commoditized, where you can have huge gains in performance simply by swapping out a newer LLM at some point. And so if they're able to process some of the ambiguity in a query and the routing portions of the query as a single interface routing, it'll solve a lot of the downstream issues we see with prompt chaining and setting up the right set of prompts.
I see. And the reason that you're going to like eventually move architectures is because you're expecting an improvement in quality, or what's sort of motivating change in architecture?
So embeddings work really well when you have a very constrained search space. So if you know your users are always asking a very specific set of questions within a given data room, very powerful. As you expose more generalizable queries to the user set and then have it routed accordingly, that becomes more and more complex. So because we're exposing greater data products to the rest of our business with varying varieties of what the context may be, we're looking to make sure that we can handle the different types of users and queries that they may put in, right? An expert in finance will ask a question very differently than someone in the field. And so we want to ensure we don't drop in performance as the language being used changes.
Awesome. Wow, that was super helpful. Thank you for sharing that. Made compound systems definitely like super clear. And then maybe Vijay, can you also walk us through what's sort of like are you all building a compound AI system or using data intelligence at State Street? Or how are you all architecting your solutions today?
Yeah, it's mostly the data intelligence part. And I think I'll sort of try to connect to what Lindsay was mentioning earlier. In the agentic approach, where you have each of the agents is optimized for certain objective functions that they're looking at, right? When you have a cluster of those, they will sort of like collaborate to arrive at the solution. A compound AI system, unfortunately, tends to be very engineer centric in its thinking, right? It's a sort of a linear, if this, then that kind of a thing that we're all trained on trying to translate into software. So we are sort of like coming somewhere in between that in our compound AI solution, right? We end up with first of all, of course, RAG centric use cases. Then I was referring to the knowledge graph, which also rolls in some of the symbolic representation of our either it is workflows that have to solve a certain problem, or have the understanding of the domain understanding of certain types of securities versus whether it is like a derivative or a foreign exchange trade. There are different nuances in what happens in those areas. So at a high level, that's one thing. But for us, the bigger challenges were, as a very highly regulated industry, as a player in the industry, we end up having to demonstrate to our stakeholders, not only internal, but our regulatory stakeholders, that we have a responsible AI system, not just everybody can have a go at it at any LLM that's out there. So we're going about curating those LLMs, and we've come up with a sort of a much more deliberate approach to you might call it LLM ops, but essentially linking the LLM in the appropriate part of the overall solution. When we make that call to the LLM, before that, or even while we are making the call to the LLM, we are not just a single LLM, multiple LLMs are involved. So we end up stitching these things together into a quilt work of functional calls, right? Function calls. And then that's what essentially is the overall structure of our solution.
I see. And do you have to track the series of calls for like audit purposes, or
Correct.
what we call as that design, basically?
Correct. So one is the responsible AI, and I'll probably just quickly show you one slide that tries to capture what it is that we are doing, which is in this notation, right? We have these. Of course, there are different applications. We just labeled them in the very broadest terms, but we are provisioning this API SDK, which essentially has all of these technical capabilities at the back end, the prompt catalog, RAG pipelines, and then prompt management, prompt security, and filtering. But essentially what we have to provision is these kinds of things. You got your jailbreaks, input guardrails, output guardrails. All of these things are built into the overall architecture. Now we are looking to.
A lot of your compound AI system is applying a bunch of guardrails on there. Really kind of like Shamir also had like some guardrails added, like check if this answer actually answered the question and things like that.
Correct. And we also have evaluation pipelines, right? So that we have to keep track of whether the response that the LLM generated was satisfactory to the overall solutions context. And then, so then there's the other interesting thing I'd like to point out. I think this goes back to the first topic that you brought up. We're spending a bunch of time on this area, fine tuning, because unlike the prompt tuning, we are learning that the LLMs have not yet been trained on financial terminology. So a leg in the financial services world, especially when you're doing a derivatives trade, means something else than a body part. Right. So we end up having to train those kinds of things. So we're focusing on this, and this is where we're getting a lot of leverage out of Databricks's the Mosaic layer. Right. We love that part as well.
Awesome. And Vijay, one of the things that you had mentioned before was as you moved into like generative AI, so a lot like your solution helps sort of like augment a lot of like the manual labor component and sort of like translating documents into like actual trades. But you said like, hey, back in the day, even though it was only maybe like 70% accurate, the 30% time it was inaccurate, you're able to like very easily figure out what went wrong. Whereas now it's like 95% accurate, but in that 5% of the time it goes wrong, you can't really debug. So can you kind of like walk through like what does it mean now that your problem space has shifted like that?
Thank you for that prompt. So the no pun intended, but the idea here is the pre-LLM world, right? We always had these deep CNN based neural network based techniques that with machine vision, where we could locate the coordinates on the page where you're extracting data from, and tie back the information that you extracted back to that thing, so that if there's something that goes wrong, you can, at least the humans in the loop can quickly triangulate to I don't want it from this part of the page or this part of the document, I want it from this other place, right? And then there was also the feedback that they could provide to improve our models. Now, what has happened with traditional LLMs? They're only linguistic. That is, they can take in text strings. They're not visual yet. And again, that whole space is being upended by like the Pixtrals and the others that have multimodal LLMs, right? So the text-based LLMs lack that fidelity to tell us where you picked up this data from in the document, right? So that gives a lot of trouble to our humans in the loop to repair the findings or the results of the solution. And that's exactly like you said it right. We were able to increase the accuracy of the information extracted, but we're not able to reduce the time to solve in its entirety.
Yep, makes sense.
If I may put it that way.
And then Lindsay, I think like the challenge that you were mentioning that you will run into is that off-the-shelf models are basically all tuned to be as pleasing and like nice as possible. And so like, why does that present a challenge for you and like what you're building with your patient AI and your conversational coaching?
I mean, so the dynamic prompting is like is a tactic towards that, be verbose, don't be verbose, right? And it needs to change based upon expected behavior at different parts of like the flow of the conversation. I think that you can also look at it from a different dimension and be like, this is an obvious fine-tuning problem. There's like two reasons why we're not taking that approach, although it makes total sense technically. One is that like we also are highly regulated and like we can't use technology till GAs, and then there's still a long cycle of friction before we deploy. So we're super excited about Mosaic too, and definitely want to use it and fine-tune open source models to be mean to us. We just don't have the approvals yet. But also like,
let's not make that our tagline though.
What I love about it is like there are unintended there are unintended consequences to well-intended solutions. And there are use cases for which you need an LLM that is toxic. And those are weird, but like they do exist. And this is an example of it. The other reason is that we don't have a big training corpus. Like physicians know what these are supposed to feel like. We have like a vibe, right? But like we don't have like thousands of examples of like really good interactions or really bad interactions that we can fine tune against. And we absolutely can't pay doctors to sit there and read a bunch and score a bunch. And you can't outsource it to mechanical turk. Right. So we had to some degree take the knowledge in a clinician's head and translate that into like some formal design, and then translate that into like you know, features and stories that we could engineer against. One other thought I just wanted to share after hearing Vijay talk here is like LLMs provide a different path to value, whereas in previous machine learning, we had to be 95% accurate, 99% accurate. If you can automate 10% of a task, like only be right 10% of the time, and like decrease the queue that humans do work 10% of the time, and you do that thing across 10,000 workers, that's huge. The ROI is monstrous. And so for those struggling to get value, things don't have to be perfect the way they used to. They can actually be pretty mediocre and still have huge value if you have the scale of a like large corporation.
Yeah. Shamir, any like challenges that you all are seeing come about as you embrace compound AI, or based on anything you've heard from like Lindsay or Vijay, anything that you want to add in?
Yeah, the thing I would add is reinforcing what Lindsay was saying, is that time to value is actually surprisingly quick for a lot of low-hanging fruit. So, you know, we've done a lot of simple things with troubleshooting manuals for our field technicians, where when they would have an issue with a particular system, they would have to go hunt through a bunch of documentation to find an answer. Now they just ask a question and they get the answer. So, you know, it's not groundbreaking work or anything that we're doing. We're just taking the existing manual, passing it through an LLM, generating embeddings, and then returning answers. But it's yielded enormous lifts in terms of productivity and resolution of tickets. So for those who are hesitant to try stuff out, I think RAG in particular with embedding-based models are very simple ways to get into things to drive productivity. Don't hesitate there. Everyone will talk about the bleeding edge stuff, but the highest return on investment and value is the boring stuff with RAG.
Yeah, awesome. Well, thank you all so much. This was an awesome panel. We had like different industries represented, different use cases. So this was super helpful for everyone. So thank you all so much for sharing. And yeah, I really appreciate you taking the time to be here. And we're excited for what you build next on Databricks. So thank you all. And thank you everyone for joining us on this fascinating panel discussion. I'm now pleased to introduce our next speaker, Ash from Meta, who's going to chat with us about open source AI and the future of the Llama model family.
Thank you, Casey. It was awesome to hear all those customer stories. Hi, everyone. I'm Ash Javeri, and I'm VP of Partnerships here at Meta. And I'm excited to spend some time talking to you about AI, Llama, and our great partnership with Databricks. Before jumping into that, I want to share a little bit of our broader vision here at Meta, and really around the two platforms that we're invested in and building. The first one is around XR and the metaverse. Here, we're building devices, software, and platforms that allow people to connect and be present in ways that they can't with the devices that exist today. And the second platform that we're very much invested in is AI. And with AI, we really believe that it's going to change the future in ways that we can't even really imagine. We're going to unlock human creativity, drive and boost human performance and productivity, and really just transform how people interact with machines in everyday life. We use AI everywhere at Meta. We've been investing in it for well over a decade, back when it was simply called machine learning. For example, we use it in our Ray-Ban Meta glasses. So when you put these glasses on and take a picture of a menu in a foreign language, you can have it translated into English or a language of your choice. We also use it in our newsfeed, which allows us to deliver billions of personalized impressions and news feeds on a daily basis to all of our users. And internally, we've deployed it to all of our developers who are using it to write better and faster and more optimized code. But here at Meta, we believe that everyone should have access to AI, and this is why we open source our models. But we have a long history here at Meta of open sourcing. From day one, when we open source products like Thrifts and Open Compute, to 2013, when we founded FAIR, which is our AI research lab, which had three core tenets to it. One, we're going to open source our models. 2, we're going to publish our papers. And 3, we're going to publish our tools like PyTorch, which has now become the industry standard for AI development. And today, we're in our Llama era, where we've started to open source each one of our models, starting with Llama 1 to where we are today with Llama 3.2. So I often get the question, why does Meta open source these models? Well, we think that there's benefits to Meta, enterprises and developers, and the world. For example, to Meta, we get a bunch of innovation from the community as we release our models. We get thousands and thousands of developers out there optimizing, pushing, making better, distilling, quantizing our models. And that really helps grow the ecosystem. That also then leads to chipset makers optimizing their processors for our models, which then drives down the cost of inference, which makes it cheaper and easier for enterprises, to use and deploy our models. If you're an enterprise, you're also able to have full control over the model. You choose where you want to deploy it. You choose what data goes into it. You don't have to send your data to another company or someone else's models. You have full control over that. You also have tons of customization. Because you control and own the model, you can decide how you want to customize it, distill it, use it, deploy it. And because of the power of the open source innovations behind it, these models become much more affordable and efficient. And we also believe that because of this and because of the thousands of people that are working on our models, they're much safer. We really believe that you should do AI development out in the open rather than behind closed doors. And we think that this leads to safer models because you've got eyes on it throughout the development process. And because of this, we think that we're very much democratizing AI, making it available to anyone, anywhere. And we think that this will accelerate human progress. So now I want to talk a little bit about the history of Llama. In February of 23, we released Llama 1 to the research community, and the results were off the charts. We got thousands and thousands of requests from people all around the world wanting to use and benefit from Llama. And so as we built Llama 2, we released that under a commercial license so that anyone out there could use Llama free of charge in an open source model. And since then, we've just continued to innovate. So shortly after Llama 2, we released Code Llama, which allows optimizations for coding and lets developers use AI to really build better code. One of the big use cases that we have internally here at Meta. We then released Llama 3 back in April. And just a few weeks ago, we released Llama 3.2 to the community. And it just keeps getting better and better and better. If you look at the capabilities of the models, context windows are getting better and bigger. The models are both getting bigger and smaller, and the performance just continues to increase. And there's a lot more that we want to do. So let me dive a little bit into Llama 3.2. We again listened a ton to what all of you out there asked us for. For example, there was a huge request, can we please have smaller models? We want to run them on mobile and we want to run them on PC. So we released 1 billion and 3 billion parameter models. We had requests around multimodal. And so we released vision-based models as well. And finally, on a safety perspective, we introduced Llama Guard, which really helps with prompts and making sure that models are safe and getting safer out there. And we think the results speak for themselves. We used over 150 different benchmark data sets to evaluate the performance, and we think we crushed it. Our benchmarks out there show that we're as competitive, if not more, than all the other models out there, and especially on things like image recognition and visual understanding. But we're not the only ones who think we're crushing it. The community out there is also giving us great feedback. We've had over 400 million downloads of the models, and that's a 10x improvement or increase from when we released the models back in 23. And there are over 65,000 derivative models out there, just showing how much the community is embracing the models and building new things on top of them, which is exactly what our vision was when we released the models. But enough about Llama. Let me talk a little bit about Databricks and our partnership. Databricks is one of our first partners to embrace Llama, and we have a fantastic relationship with them. They offer all of the Llama models, including the 405B model, which is a game changer because of the special capabilities that it unlocks. Things like distillation, which you just can't do with smaller models, or synthetic generation, which these large models excel at. And you can even use this 405B model as a teacher model, which means that you can take it and train smaller models and make them more efficient and optimized. And our customers also agree. Here's just some examples of companies who are benefiting from the Llama and Databricks partnership. Companies like First American are using Llama to extract data from their property records, and the crisis text hotline is improving real-time crisis interventions. So I've covered a lot of technical details today, but I also wanted to try to just help visualize what all of this means. Here's one of my favorite examples of how much progress we've made in AI in such a short amount of time. This starts with a cartoon giraffe in 2023 when I asked Meta AI to generate a giraffe riding a bicycle. And what you see is the evolution and the progress of that from a cartoon to a realistic giraffe to what you see on the right of the screen here, which is a photorealistic giraffe riding a bicycle down a country road. Soon, we'll be able to animate this so that you can have this giraffe riding towards you in a movie. And soon after that, bringing our AR vision into this, we're also going to be able to have this giraffe as a hologram pass in front of you while you're wearing our glasses. So this really is just the beginning of where we think things are headed. And I've covered a lot today, but let me try to summarize before I hand it back, which is, one, Meta is incredibly invested and committed to open source models. Two, we think very much that the Llama models are state of the art, and you're able to get started today with the models by clicking on the link here. And we're really excited about our partnership with Databricks and all the things that we're building together. And now back to you, Naveen.
Thank you, Ash, for sharing all the exciting progress that's going on at Meta with the Llama program. We're really excited to continue partnership and roll out these models to the enterprise. So with that, I just want to wrap up and summarize what we talked about so far today. With Databricks, you can identify a generative AI use case and define success criteria. This is really the tools that we have for compound AI systems and automatic evaluation. Defining what a POC looks like is actually a really great first step. When we do this with customers, we usually like to find something that's high value, that if solved, can be rolled out to production and have immediate impact. So work on a POC for RAG or fine tuning or something even for pre-training if that's required for your application. And then engage with the Databricks professional services or system integrators. We can actually help you get that application built and then actually take it to production. On your own, we actually have lots of different materials on our website. You can take the free generative AI course that we put together. It's actually really quite nice. It gives you all the fundamentals and exposes you a little bit to the Databricks tools and ecosystem. And you can even play with the Q&A chatbot demo augmented with your data. So if you have a Databricks instance, you can actually play with this demo yourself, or I think you can go to a sandbox version. And you can try out models in the Mosaic AI Playground. This is a really nice prototyping tool that we built. It allows you to modify models and systems, build RAG, build fine-tune models, and then go and demo them within an easy-to-use front end that kind of looks like any chat interface. So with that, I'd like to thank you all for your time, and please reach out, engage with us if we can help build your next AI solution.